Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, let us solve one more problem for single stub matching. Here we are asked to use a single stub tuner to match a line to its load whose normalized load admittance. So small YL, that is YR by G naught, is given as 2.75 plus J 1.75. We are asked to use a shorted stub. Okay, and calculates its distance from the load and the length of the stub by using the Smith chart. So we are asked to find the shorted shunt stub tuner with a particular distance and particular length. Okay, so we see here, this is the schematic or representation of the given data. This is the transmission line connected with a normalized load admittance, and at a particular distance D stub. Okay, we are going to connect the short circuited stub of length L stub, right? So we are supposed to find these two parameters. So we have to consider, as I told earlier, this is the admittance chart because we are connecting a parallel stub, right? So in admittance chart, first task is to locate this normalized load admittance. Okay, that is 2.75 plus J 1.75. So if you could see here, 2.75 is lying above this 3 value, and coming to 1.75, this is 1.4, fine, and this is not 1.4, this is 1.6, and this is 1.8. 1.7 will be here, so 75 is in mid of that. So the intersection of these two is point P where normalized load admittance is available, right? So now we are going to draw a straight line connecting the center of the Smith chart and this point P, taking that as radius, draw a VSWR circle. After drawing the circle, what we have to do, we have to extend this line OP to the outermost circle to find at which location the load is available. The load is at 0.221 lambda. Okay, it is lying before this scale, right? So 0.221 lambda. Now our task is to trace R equal to 1 circle or G equal to 1 circle so as to make the real part of this normalized load admittance to 1. To make this 2.75 to 1, what we have to do? We have to move along this VSWR circle clockwise to reach this point P. So after tracing the circle, VSWR circle and R equal to 1 circle intersects at 2 points. This is point A and this is point P. So we, after moving this particular point, our resistance circle is 1. We have made it. Now we have to find what is the reactance available at this point. That is minus J 1.5. Okay. So what we have to do to find the distance of the stub, we have to see the distance between the normalized load admittance and the point B. So we have to draw a straight line from the center crossing this point B, or that straight line should extend outwards. Seeing the distance between these 2 points, load is available at 0.221 lambda. This B point is available at 0.324 lambda. Fine. So this is my distance of the stub D stub, right? 0.103 lambda. Whereas to find the length of the stub, so what we need to do, we have to find the reactance value. Okay, the opposite reactance, this plus 1.J5 we have to find. If you trace the point A and find what reactance available, it's plus J 1.5. That R key we have to extend outwards, and that point, what is the wavelength you have to see, that is 0.156 lambda. So from the short circuited stub location, short circuit position location to the point A is the length of the stub. Point A is available here, the extended version available here, this value. So from the short circuit, we have to move clockwise to find the length of the stub. So this between the short circuit and open circuit stub, we have moved a distance of 0.25 lambda. Plus we have to add this particular wavelength to find the length of the stub. So the distance and length of the stub is our desired answer.